Today we're going to look at how to take images from the internet and create artwork from them using RDXWorks and a variety of other tools to burn laser images onto various materials. Welcome to Making the Space. I'm Pat Schuff. We will start by downloading a publicly available image, one that has no copyright or copyright infringement on it or trademark, and do that. Go to Google, do a quick search. We're going to use a drama mask as a very simple way of doing this. Once we find a design that we like, we follow it to the source and make sure that the image is listed as non-copyright and available for production use. Last thing you want to do is steal something from Disney, like the Mandalorian image, and put it up for sale because they'll hit you with copyright infringement. Note this image says that it's available for personal use, which means I can't create artwork based on it and resell it in an Etsy shop or some other location. That's perfectly fine for the use of what we're trying to do. We're going to take the image, take it into RDWorks. Well, first we'll download it, then we'll move it into a folder so we can find it again, and then ingest it into RDWorks so that we can rasterize it. The RDWorks program is not the best program to copy images and vectorize them, but it is the tool that we use to burn at TXRX for all the laser cutters. The software is hooked up to all of the various laser cutters, so learning how to use this tool is the easiest way. It's not necessarily the best way. So let's go through an example of how to take an image and rasterize it. So the first thing we want to do is import the image, and it brings it in as a JPEG image, and we can scale it and move it and make it as big or as small as we want. Once we have the image scaled, then we'll go in and handle it with bitmap corrections. To convert the image, we go into Handle, Bitmap Handle, and select No for using the tool, and then we can just generate an outline based on the tool that exists as part of the RDXWorks. Once we have the outline, we can delete the original image, which will give us just the outline, which is basically what we're looking for. This is a very easy way. We can go in and manipulate it and change it. What we're going to do in this example is merge the two masks into one unified mask as opposed to two separate masks. If we zoom in, we can see the different points that are used for rasterization. Notice it puts a point pretty frequently around. It's not necessarily a smooth line. It's not necessarily a continuous line, which is one of the drawbacks of RDXWorks. But we can go in and separate these lines, delete them, and then merge the two masks together relatively easily. So in the video, we basically went into the outline of the two masks, separated it so that we could isolate a gap between the whole outline section and deleted those sections. The next is we're going to join the two masks together at the top, at the bottom, and then delete the lines that separate the two masks. Once we finish the process at the top, we repeat it at the bottom. We select two small segments, we break the lines, we delete the lines, and then we join the outer edges of the mask, and then delete the long lines that represent the separation of the two masks. Once we get rid of the separator lines, we can join the two masks at the bottom, and in effect have customized this image and made it our own. So since we've modified it, we no longer have personal use license, and we can freely make this a commercially available license since we've updated it and modified it and created it our own. The final step in this design is to select a different color for the outside and a unique color for the inside, because we want to cut the insides first if we're going to do a cut through, or if we want to etch them as opposed to cut them. We want to be able to give it a different command. So we select the outer cut, which should be the unified piece that we just created, and give it a new color, and then we can customize the cut. So before we take this to the laser cutter, the first thing we need to do is save it to disk so that we can copy it to a USB or download it from the internet, and then verify that we have the proper scale. Make sure we're the right size, we're cutting it as large or as small as we want, and verify the cut order to make sure the inside cuts first. Based on which laser cutter we're using, and if we're doing a through cut or an edge cut, we select the power and the speed, because the power and speed determine if it's a clean cut through or a partial cut through. For acrylic, we're looking at a speed of 3, a power of 90 to do a clean cut through. Before we cut on the large laser cutters, we need to calibrate the laser, and that's done by using a spacer and manually adjusting up and down. On the small laser cutters on the other side of the lab, autofocus will automatically zoom in and zoom out. The next thing to do is verify that the size and shape of the object is appropriate. If we've scaled appropriate in the design, we should be able to click on Go Scale, and the laser should cover the path that it's going to cover for the largest box around the area. Once we're happy with the position and the calibration of the laser, we tell it to cut, and it begins cutting in the cut list that was described. The first thing that it should cut is the inside of the mask. Once it finishes that, it then will cut the outside of the mask, and we can measure the progress on the monitor on top of the laser cutter. Once the laser starts moving, we can see the diagram on the monitor on top of the laser. It's best not to look at the laser to look at the progress. You can pause and open the lid and see how things are progressing. Make sure it's doing what you're expecting. But best practice is not to watch the laser from the side. We're using a camera to record this, so it's not damaged to your eyes by using a camera. When we get to the end of the diagram, you'll notice the time it took to actually do all the work at the bottom left-hand side of the screen. And a beep will happen when the cut is finished. We can open the lid, remove the pieces. It's suggested not to touch it and make sure that everything cut through, because you can cut a second time, but if you move the piece, you can't cut the second time. So we're going to take this same design and cut it out of plywood so we could have a plywood backer on it if we wanted to behind the acrylic, or do a variety of things like paint it and put silver paint on it to make a mirror if we wanted to. The key element here is we need to recalibrate the laser because the plywood is a different thickness than the acrylic, so we have to go through the whole process all over again. The exact settings worked on plywood, so the laser speed and the laser power worked out perfectly. Things went through, things cut, and we can compare and look, make sure they cut the same size. So what we'd like to do a little bit different is take the plywood and scale it so that we can have a 2D image. We have the cutout mask, and then behind it we have just the outline that we've scaled to a larger size. Unfortunately, the scaling doesn't work exactly how you think it would. It doesn't move all of the edges 1.5 inches out. Instead, it scales the whole image by a percentage, and you can use other tools to make it scale appropriately. When I first cut the background image, I realized I made a mistake. I started to cut the details as opposed to the outline, so I had to stop, shift the cut down a little bit, flip what was being cut as opposed to the black lines, which are the interior lines, to cutting only the red lines, which is the exterior. Once the cut was finished, I was able to take the piece out, scaled, just the exterior cut, and place it behind the original. And at that point I noticed it didn't scale quite like I was expecting to. I was hoping it would push everything out by 1.5 inches, which is not scaling. That's a different function, a different operation, and you basically have to go back and redesign it using Illustrator to make it bigger by a certain fixed amount. Now the second test I tried was to cut the acrylic and the plywood at the same time. This turned out to be a horrible mistake. It didn't work at all. In fact, I shouldn't have done it because it was basically a fire hazard. The back side of the acrylic melted and caramelized. The front side of the plywood burned. There was an air gap between the two, which created a vacuum and a way for fire to be trapped inside, as opposed to be pulled through with the air handler and clean things out appropriately. One of the nice things about the lab is there are templates and guides to show you the power setting and the speed setting to be able to do etchings, to be able to do cuts on acrylic, on plywood, on leather, so you could use a variety of materials. One of the things is worthy of playing with is looking at cutting versus scanning. If I cut something, it's going to cut all the way through the paper. If I scan, it's going to etch. So I like to use cardboard paper as an experiment because it's cheap, and I can go in and say, let's scan, which takes a lot longer because it's rasterizing, and go through and generate a etched image on top of a piece of paper. One of the drawbacks of RDX tool is it's not a good rasterization tool. If we blow things up and look at things that are scaled, we'll notice very rough edges, very jagged edges, and things that can be a whole lot cleaner. If you use something like Adobe Illustrator, which we'll demonstrate in a later video, I can get rid of a lot of these artifacts. By blowing this up to something that's 2 feet by 2 feet, it's pretty ugly. It's important to note that you can play. Things like leather, things like fake leather, things like thicker leather allows me to go in and do etchings or do line drawings. They don't have to be square. You can go in and cut pieces of wood in a surfboard shape, for example, or holes through an image to create a three-dimensional saying or mosaic or woodwork. I can also use acrylic to fill in the etched out pieces to make it look nicer on wood, and then put a resin fill on top of it. It's fun to play with a variety of things, and if I'm not selling it, I can use private images. I can use things like Disney images or licensed images from John Lennon or the Beatles, or however I want to, because I'm not selling them and it's free for me to play with.
Now back to your regularly scheduled program.
And while some may see them as the crazy ones, we see genius. Because the people who are crazy enough to think they can change the world are the ones who do.